Good evening to all of you. Honorable Vice Chancellor Dr. Ravindran inaugurated the Faculty Development Program on empowering education with next-gen computing, AI, supercomputing and data science. Dr. Mohammed Gutti, Principal, Majlis Arts and Science College and coordinator of this Faculty Development Program. Dr. E.J. Thompson Frederick, the resource person for the second session. Professor, Department of Computer Technology, Karpagam Academy of Higher Education, Coimbatore. Mr. C.P. Hamza Sahib, Honorable Member of Syndicate, University of Calicut. Dr. P. Muhammad Ali, Chairman, Majlis Academic Board. Mr. Naushad, Academic Director, Majlis Arts and Science College. Mr. Rafiq, Coordinator, Faculty Development Program. And IQC Coordinator of Majlis Arts and Science College. Mrs. Shamima and Mrs. Vichitra, Assistant Professors of Computer Science Department. Mr. Subhash, who provide the technical support. And all the delegates across the country who has assembled here for attending this Faculty Development Program. A hearty welcome to all of you. Now we have the second technical session on FTP on neurofuzzy approaches for time series prediction and forecasting. And as far as I have been informed, neurofuzzy system has great applications in medical diagnosis for identifying diseases, financial forecasting in stock market trends, image recognition, etc., etc. And our resource person, Dr. E.J. Thompson Frederick, is an accomplished academician with more than 22 years of experience. He has served as a senior lecturer at INTI, International University, Malaysia for 6 years. And currently, he is professor in the Department of Computer Technology at Karpagam Academy of Higher Education, Coimbatore. He has his PhD from Bharatiyar University in Computer Science in 2014. And Dr. Thompson has created 12 PhD scholars in Computer Science and has authored 50 research papers in reputed international journals. He has published 4 patents in the field of artificial intelligence and has presented 20 research papers at national and international conferences. He has also authored 2 books and contributed 4 book chapters to Springer lecture series. His key areas of expertise and research interest include data mining and artificial intelligence. So we have an eminent academician and experienced teacher and seasoned researcher for the next technical session. On behalf of the whole academic community who have assembled here, I extend a hearty welcome to you, sir. Thank you.
Thank you, ma'am. Thank you for your nice introduction. Can I start the session, ma'am?
Yes, sir.
Thank you. Good evening, everyone. Thank you very much for Majlis College for this wonderful opportunity for me to act as a resource person in this Atal FDP seminar. Okay, today my topic is neurophagy approaches for time series prediction and forecasting. Okay, agenda for the today's session is first. So let me introduce the overview of time series forecasting. Next, overview of what is neurophagy system. So next, what is the architecture of neurophagy model? So next, what is the learning and the model learning algorithm for neurophagy model? Then what are the benefits? Then I will take the small case study for how the neurophagy model can be applied to stock market. Then next, what are the challenges? Then finally, conclusion. So first overview of what is time series prediction. So basically, time series is a sequence of data points indexed in time order. For example, if we take every day, we implement time series in our brain. For example, if we take our sleeping methodology from Monday to Friday, then we can draw one simple graph. So Monday, how many hours we sleep. Then Tuesday, how many hours we sleep. Then Wednesday, how many hours. Then Thursday, Friday, Saturday. Then if we draw the graph, then each and every day, how many hours? Then maybe 4 hours, 5 hours, 6 hours, 7 hours. That it is the example of time series. Then we can analyze. For example, if our sleeping hour is reduced, then automatically our brain get damaged. Then we get stress and we get automatically get health issues. So that is one simple analysis of our health sleeping hour time series. That, for example, in time series, data is collected over regular intervals. Then another thing is the time series exhibit patterns like trends and seasonality. For example, if you take the traffic analysis, then traffic system, then for example, morning 6 o'clock until evening 6 o'clock, or morning 6 o'clock until night 10 o'clock. Then from morning 8 to 9 or 10, the traffic is peak hour. That is the traffic is very busy and also traffic is congested. That is a trend. 8 to 10 is traffic is very congested. Road is very congested, busy. Then seasonality is depends upon the specific time, depends upon the, for example, if we take in Kerala, we take Onam festival, then the traffic will be very high. In Tamil Nadu, if we take Deepavali time, then automatically the traffic will be peak. So that is called seasonality. Then another thing is, so what is the difference between prediction and forecasting? So for example, you take prediction. Prediction is a broader term for estimating future outcomes. And another thing is forecasting is a subset of prediction because so under the prediction only forecasting coming. Prediction always know we what will happen in the future. Forecasting must do only on the historical time order data. For example, if we take tomorrow is so match between India and Australia cricket team, then how we forecast whether India will or Australia will is we will do the analysis on historical data for the past 10 years or for the past 20 years how Indians played and then how Australian team played based on the historical cricket data, then the batting and bowling. Then only tomorrow we'll forecast whether India will or Australia will. That is called forecasting. So next, for example, time series forecasting. So we can implement in the finance system. For example, we can implement in Indian economy or weather forecasting. Tomorrow it will rain or tomorrow we'll get cyclone and moreover healthcare related applications. Then what are the challenges is so most probably we won't get linear data. The data will keep change, will go up and down. And moreover, we will get the noise in the time series data. Noise is the unpredictable change during the transaction. That is called noise. Then let's take what are the characteristics of time series data. Time series data is collected at fixed intervals. It may be daily or weekly or monthly. So we have the characteristics like trend. I already explained. So trend means how the data will be affected. For example, if we take supermarket, then the Saturday and Sunday the sales will be very high. That is called a trend. Seasonality means during the festival time, during the specific period, the sales will be high. Cyclic variation means so sometimes it go up means sometimes it will come down. So that is called cyclic variances. Another thing is automatically in all time series data we get noise. That means we get some unpredictable change and unpredictable data during the transaction. That is called noise. Then time series is affected by external factors like climate condition, then economic condition, and also human behavior. Human behavior is if 100 staffs or 100 faculty or 100 people are working in the company, suddenly 20 people they quit the company, then automatically what will happen? The time series will get affected. Then, for example, we take traditional forecasting method. So, what are the traditional forecasting method for the time series? Is first thing is moving average. So, how moving average is calculated is first what we can do is, for example, we take supermarket data. The supermarket, the manager, if you want to do analysis, how much they can do they have the sales for the past 3 weeks for only specifically cosmetic items. Then we will take week one, what is the sales? Then week two, what is the sales of cosmetic item? Then week three, what is sales amount of cosmetic item? Then we can take average. That is called moving average. The next thing is exponential smoothing. Exponential smoothing is so we can forecast depends upon our the data. For example, we take electricity board in any government. So they will predict what is the electricity consumption will be tomorrow. For example, we take during if it is summer season, then the electricity consumption will be very high. Then during winter season, electricity consumption will be low. So that is called exponential smoothing means if we are in the May month, then summer season, then automatically the consumption will be keep on increase. Then winter season, automatically electricity consumption will keep on decrease. That is called exponential smoothing. So next thing is so ARIMA model. ARIMA means auto-regressive integrated moving average. That means it combines auto-regressive model and also it integrates with moving average. So it combines two model. So something like it is hybrid model. Then it implement for non-stationary data. Non-stationary data means stationary data means the data which gives smoothie. Smoothie means, for example, if we are using air condition, the temperature is only the varies between only 24 to 26. That is called it is smoothie data because the data keep changing only to either temperature 24 or 25 or 26. At the same time, if the temperature it keeps on coming down and increase, for example, if the temperature is 17, suddenly it increased to 25, then again it comes to 20. It is called as non-stationary data. Stationary data means the interval is the very less and also the intervals the quantity is very less. So next model is Arima model. This is called seasonal Arima model. So it takes account of seasonal patterns in the addition to the trends. So next thing is regression analysis. So it establishes relationship between variables to predict future values based on the correlation. So it implements some statistical technique called regression for finding out the how the time series the data will be next in the next 5 years or next month or tomorrow like that. So next we are having we need to find out the what are the benefits of neurofuzzy method over the compare ARIMA method or other methods. For example, if you take neurofuzzy method, then when you compare it to ARIMA model is so automatic regressive integrated moving average. So neurofuzzy will handle non-linear patterns. Non-linear means So linear means the data will which keep on increasing or keep on decreasing. That is linear pattern, something like straight line. But if the graph goes zigzag line or parabola or curve, then it means it is considered as non-linear pattern. So neuropathy deals with some complex data, but the traditional method like ARIMA model or moving average, then it deals with only simple data. The next thing is if you compare with deep learning model like LSTM, long short-term memory, then neuropathy provide interpretable results, and the training time, so minimum training time, it provides the very good output. So benefits of neuropathy system is it leads to high accuracy output, then it handle the uncertainty data, then moreover even we have the unsmoothy data and noise, it provides better output. So next thing, overview of fuzzy logic concept. So the fuzzy logic is introduced only in the year 1965. Okay. So let me ask one question. Anybody can tell what is the difference between fuzzy logic and Boolean logic? Anybody? Because this is only simple question. So just I want to ask fuzzy logic and Boolean logic.
Boolean logic takes the value 0 and 1, whereas fuzzy logic's like it comes in the range of 0 to 1.
Yes, ma'am. So everybody knows because if we study in artificial intelligence, though this is the basic question, but many people will consider like Boolean logic is different, fuzzy logic is different. But fuzzy logic is derived from only Boolean logic. Fuzzy logic is introduced only to in order to overcome the limitations of Boolean logic. So that is the reason Lotfi fuzzy the Lade, Jade scientist, he introduced the fuzzy logic concept in the year 1965. For example, you take fuzzy logic, it deals with a linguistic variable and also partial truth values. Linguistic variable means, for example, in our human brain works only on the basis of linguistic variable. So we will tell only like this: the road is very busy, the car driver is driving very fast. We won't tell the car driver is driving at the speed of 100 kilometer or the car driver is driving at the speed of 40 kilometer. We tell car driver is the driving his car very fast. So very fast means, so that is called, here come uncertainty, and it gives to vague time. Vague time means very fast means how much kilometer. So we cannot determine because our brain only thinks like that very fast, or we'll tell the particular student is very clever, the particular student is very good. Very good means what? Whether the student academically strong or whether the student discipline wise very good. So that is here the things coming, the vague terms and also uncertainty only comes in the linguistic terms. So that is the reason fuzzy logic deals with this kind of linguistic variables. Then the linguistic variables are converted into fuzzy values from 0 to 1. For example, if you take the student is very tall, then what is the height of the student? Suppose the height of the student is 175 centimeter, then we fix the fuzzy value. Maybe for him, fuzzy value is 0.8 or 0.9. So that is called how the linguistic variables are converted into fuzzy values. Then fuzzy logic introducing only if then rules for reasoning. Then core components of fuzzy logic is first we need to fuzzification. Fuzzification means we convert the linguistic terms or whichever things are vague or uncertain and also unprecise, we make into fuzzification. So fuzzification is implement fuzzy membership function to convert the normal value into the fuzzy values. Then inference is applying the fuzzy rules. Then after applying fuzzy rules, we get some fuzzy value. Then fuzzy value we again convert it into normal value. So that's how we implement defuzzification function. Then limitation of fuzzy logic is so no automatic learning. But if we give lot of rules, then then what happens is if we give like a large data set like 10,000, 12,000, then fuzzy logic cannot work. Then another thing is So every time we need to tune the membership function manually. So these are the drawbacks of fuzzy logic function. So that's why we go for fuzzy logic with neural network. So if you take neural network, so everybody knows. So if we study artificial intelligence, so we get the idea what is neural network. So neural network is so biologically how our human brain works, how our human so duplication of working of our human brain, that is called a neural network, because in our human brain, so we have so lot of millions of neurons. So our human brain working is the neurons are getting communicated and neurons getting connected, and our tasks, so maybe we writing, reading or eating. So the tasks are performed by human brains. For example, if we take, so let me ask one small simple question. So who is the greatest scientist of 19th century? Anybody can answer? Who is the greatest scientist of 19th century? Okay, let me tell the answer. So, greatest scientist is there are so many scientists, but the greatest scientist the history considered as Albert Einstein, because he received the Nobel Prize for 2 times. Then he introduced the formula E equal to mc squared. So, why I talk about Einstein is after the death of Einstein, then the neurologist and the scientists they want to do research on Einstein brain, how Einstein brain work extraordinary comparing to the other people, then how he can able to solve complex problem, how his intelligent quotient level is very high, like that they did research. But the output is the neuron connectivity comparing to the normal brain and the Einstein brain is higher. So that is the output they provide after the research analysis of Einstein brain. So that's why I'm telling how our neurons are getting connected. That is the reason how our task is performed intelligently. Then, for example, in say instead of human and neuron, biological neuron, in neural network we introduce artificial neuron. Then, moreover, if we take neural network, so we have the layers like input layer, hidden layer, then also output layer. Then the weights are getting adjusted. For example, if we want to train the neural network of alphabet, so we need to show the we need to draw the which is how is A will be written, how is B will be written, how is C will be written. For example, if you want to implement neural network technology for writing the understanding or recognizing the human handwriting, then everybody will write a put A in one style, then B in one style, C in one style. Then we need to train the computer, we need to train the software how A can be written in different style of different people. Then the neural network recognize. So even we write the A in different style like this, it should be considered as A. So that is the thing is so adjusting the weight. So suppose the neural network instead of A it is telling B means we need to correct the neural network. Then neural network would learn like a small baby. The another thing is neural network is powerful for complex and also non-linear problems. So in our presentation, in my presentation, I using integration of neural network and also fuzzy logic. So why I'm integrating means it provide better output. First thing is it combines interpretability with learning ability. Interpretability means so all humans have interpretability. Interpretability when you once you study any language like Malayalam or Tamil or English, so our knowledge is stored. We have stored the vocabulary. From the vocabulary, automatically we interpret what is the meaning of this sentence, how the sentence are connected. Because our human brain is working phenomenally for producing the meaning and also for producing the questions answer from our recorded data, and also learning ability. So human brains got learning ability. So that is the reason even after 50 years, 60 years, we can learn new things. We can learn any new instrument or we can learn any new technology. Second thing is so neural network optimize fuzzy parameters. Third point is fuzzy logic enhances neural network generalization. Fourth, this hybrid structure enables adaptive rule formation. So, since we are using hybrid model, the rules can be adaptive. Adaptive means depends on the situation. The rules can be changed. But it take normal fuzzy logic, the same set of rules will be followed. For example, if we take nowadays the many electronic machines companies, AC companies are introducing artificial intelligence in their AC machine. How it works means, so it adapts to the room temperature. For example, if we take in the particular hall, 100 students are sitting, then automatically the AC will arrange then how the temperature can be adjusted for under students. How it analyze means it will take because as the human being we inhale oxygen and exhale carbon dioxide. Then if under student sitting in the hall, then under student they exhale carbon dioxide. Then the sensor from the AC machine, then it will sensor how much carbon dioxide is inside. Depends upon that it calculates how many people are sitting, then it arrange the temperature of the hall accordingly. That is called adaptive rule. Adaptive rule means depends on the situation. The set of rules can be changed. Which rule can be fired first? Which rule can be fired next? The rules set of rules will the execution of rules can be changed. That is called adaptive rule formation. Then, if you take a traditional forecasting method, for example, automatic regression or moving average or automatic regressive integrated moving average, so they rely on only statistical methods. Then another thing is this traditional forecasting method like automatic regression or moving average, they require only stationary data. Stationary data means data should be smooth. The interval should be very minimum. Suppose the data goes up and down like stock market, or the data goes up and down like our day-to-day life, then the traditional forecasting method cannot deal. The another thing is traditional forecasting model only deal with linear relationship. So next thing is, so the traditional forecasting model only emphasizes historical patterns and trends. Suppose some data is missing, then some data is lost, then the traditional model cannot they do the output. Then high interpretability but limited flexibility because the traditional model has only limited flexible, even the data keep on changing, some noise introduced, some sudden pattern or some sudden change in data is introduced, then the traditional model cannot work. Then what is the motivation for neuropathy model is first it combines strength of both wells, strength of neural network and also combines strength of fuzzy logic. Second thing, it handle uncertainty with non-linearity. Third point is adaptive and also self-improving. Even the it cannot produce output in the first time, then it keep on training. It keep on gives if we keep on training the neuropathy model, then the output will be improved. Then another thing is the prediction accuracy will be better than normal models. So that is the motivation of neuropathy model. Then if we find the benefits, so it since it hybrid both neural network and also fuzzy logic, it provides more interpretability. Then the fuzzy parameter, it automatically tune the fuzzy parameter and also automatically adjust fuzzy membership function. The next thing is it handle any uncertain data. Uncertain data means and also vague data. For example, if we go to restaurant, if anybody tell chicken is very hot, then it has two meaning. Chicken is very hot means whether the chicken is temperature is very high or the chicken the cook they put more spicy in the chicken. So that is two meaning. So these kind of vague terms and also uncertain terms. Tomorrow it will rain or not. Tomorrow the Indian team will win or not. So this type of uncertainty data, then the neuropathy will handle better. Then let's see the what is the architecture of neuropathy model. So in the neuropathy model, first we have the classification process. Classification process is the normal data is converted into classification using the fuzzy membership function. So after that, so we what we do is so we implement the rule. What are the rules we can implement? Then we implement normalization process. Normalization process is So if we have 100 rules, so which rule can be fired? Which rule can be skipped? Then finally, what is the output we will get? So if we study the what is ANFIS algorithm, ANFIS means adaptive neuropathy integrative system, that is called ANFIS model. So ANFIS model is hybrid learning approach. Then in the hybrid learning approach, first we implement forward pass. So forward pass means, for example, if you are climbing on the mountain, then so once we climb on the mountain, our aim is to reach the peak. So our aim is reach the peak means we go only slowly and step by step. So if it goes correctly, then we go on the correct follow path. Then suppose if we take if our steps are wrong, then we are going to the wrong direction. Then we implement backward pass. Backward pass means we come down again, then take the correct path. That is called backward pass. So for the backward pass, we implement gradient descent process. So gradient descent process. So automatically, what are the error we committed? What are the error we did? So the error will be adjusted, the error will be corrected in our process. So next thing, error minimization. So error minimization is same like the small baby. So if the baby is telling the rhyme is wrong, then we will give advice. So this here you are pronouncing wrong. So this pronunciation is need to be improved here like that. Then what happened? The baby will sing the song next time correctly. Again baby will sing the song wrong, then we give some correction, then finally after 3 or 4 times the baby will sing the song or rhyme nicely. So same like that, we correct the error, we minimize the error, then only we'll get the final output. Then fast convergence means our aim is how to get the correct output. Until we reach the output, so we will need to train the system to minimize the error, then to maximize the output. Well, let's see how the ANFIS algorithm is work. First step one is, so we need to initialize FIS structure. FIS means fuzzy inference system. Fuzzy inference system means we need to define the set of rules. What are the rules we have to implement? Then how the rules can be executed. That is called fuzzy inference system. Then for fuzzy inference system, first you have to define the input, then membership functions. So membership function, if we take fuzzy logic, we have a lot of membership function like Gaussian functions, or bell-shaped membership function, triangular membership function, and also trapezoidal membership function. Depends on the situation. Suppose we have the simple system for something like a air conditioned machine, then we can go for triangular machine, triangular fuzzy membership function. Then if we have some Gaussian, if we need to implement Gaussian membership function, if we have some complex data, if we have some unlinear data, then we go for Gaussian function. Same like that. If simple means triangular, then complex means we can go for Bell membership function or Gaussian membership function. Then in the second step, forward pass. So what are the thing we implement? First layer is specification. Second layer is rule firing strength. Rule firing strength is we give the which rule can be fired first. We give the priority for the rules. So rule 10 will get fired first, or rule 5 is fired next, or rule 6 fire will be, rule 6 will be executed next. So we give the priority order for the set of rules. That is called rule firing. So third layer is normalization. Normalization is if you have 1,000 rules, out of 1,000 rules, how many rules can be selected, how many rules can be thrown out, how many rules can be skipped. That is called normalization process. So finally, rule output, how the rules are providing output. Then the rules output are tuned into final output. So step three is, so update consequent parameters. So in the consequent parameters, we implement the technique called least square estimation. Least square estimation, why we take square means the negative values are converted into positive value. That's why we go for square estimation. Then update consequent parameters. Why we go for this method is fast optimization. So step 4 is, so update anti-sectant parameters. So in this process, we use gradient descent and also update membership function parameter for adjusting the weights. So in the step 5, we compute the errors. So error we get minimum error, or maximum error. If we get minimum error, then again we go for back propagation method. Then we go for backward pass method to correct the errors. Then until we get minimum errors, then we keep on implement this process until we get output is converged, until we get the correct output. For example, if we take Mount Everest height is 8,841 meters. Then until the mountain climber reach the Everest peak, then he keep on climbing. So once the Everest mountain top is reached, okay, he got achievement. So he make the record. So and something like that. Until we reach the final output, we keep on implement this process. We keep on implement back propagation and also forward pass to reach the final output. Then summary of the adaptive neurofuzzy inference system algorithm. First step one is initialize fuzzy inference system. Second process implement forward pass. Third one least square error, least square estimation update. Fourth one gradient descent update. Then like this we implement. So if we take the flow chart, so first initialize the fuzzy inference system, second forward pass, third is update consequence, fourth is backward pass, next is update antecedent, and then finally we compute the error. Then if the error is minimum, then we stop the process. Then what are the advantages of ANFIS algorithm? Then first thing is, so it combine least square estimation and gradient descent. So it provide more accurate parameter tuning comparing to the ARIMA method or moving average method like that. Second advantage is faster convergence. Faster convergence means so the output we need to get the final output. So the final output we can get in minimum time. Third point is effective handling of non-linear system. Non-linear system, like for example, if you take the stock market, it's another thing, the weather forecasting, whether the cyclone will form or rain will come or what will happen, then this kind of non-linear systems, the neurofuzzy model will handle very better. So fourth thing is adaptive membership function tuning. Automatically, the membership function will be tuned based on the rules, based on the situations, based on the situation input. Then automatically the membership function will be tuned and the rules will be fired. So final advantage is high interpretability. So where we can apply neurofuzzy system? First thing we can apply for stock market prediction. Second, we can apply load forecasting in power system. Load forecasting is, so already explained how much electricity we need in the month of October, how much electricity we need in the month of November, then how much electricity need the Tamil Nadu or the Kerala people or whole India need in the December month. So in this application, we can implement neurofuzzy system. Third is we can implement for weather forecasting and rainfall forecasting. So fourth application we can implement for medical diagnosis. For example, if you take if you want to analysis our human brain, then human brain got, if anybody fall from the bike, if they got bike accident, then immediately if the head is affected, then when the MRI image is scanned, then from the MRI images, then the neurologist will check whether how much the brain got damaged, brain got a blood clot or blood is bleeding. Like that, from the MRI images only the neurologist are come to conclusion. Another thing is the brain got tumor or brain got shrinking. So this kind of medical diagnosis, then neuropathy system can be very helpful in this kind of MRI image analysis, MRI image scanning, MRI image processing. Then we can implement neuropathy system. Then traffic flow prediction also we can implement neuropathy system. Then let me take the stock market price forecasting, how the neuropathy model, the NANFIS model can be implemented in stock market forecasting. Because why I take stock market is stock market so non-linear and uncertain behavior. Today the stock price go up means tomorrow stock price value will come down. The another thing is the traditional linear models often fail in case of the stock market model because stock market is high volatility. High volatility means we cannot predict, we cannot determine how the stock market value will go up or down. Because, for example, in the year 2016, suddenly central government implement demonetization. Then totally the stock market went down, Indian economy went down, GDP came down. Then total the Indian economy scenario is suddenly changed. Nobody predict because once the demonetization introduced in the night time, during the next day itself, the stock market collapsed. Then, moreover, Indian economy, everything is suddenly changed. So that's why stock market is considered as a volatile market. So next thing is a neuropathy works like how our human brain works, how the human brain implement reasoning process. Then same kind of reasoning process, same kind of methodology implemented in neuropathy model. Then it is effective for prediction and also forecasting. So the motivation is the stock market values are unpredictable, then adaptive to the situation. Because adaptive means if suddenly the prime minister gives some new announcement, suddenly finance minister, no, last month when the announcement is given, the for example the taxes are reduced, GST is reduced for product, automatically what happens, the stock market boom. So depends upon the government move, government implementation. Then stock market also keep on fluctuating and changing. So that is the reason stock market is a suitable example for implementing neuropathy model. Then workflow for stock market forecasting is, so when if you take stock data, so first we implement pre-processing. Pre-processing means we remove the unwanted data, which data is relevant. So those data only we use. So we will throw away the unwanted or unclean data. Then we choose only relevant and useful data for the processing. Next thing is we implement feature engineering. So feature engineering is, so we implement the features, we take the feature engineering process, we take the good features from the process. Then which are the features, unwanted features, then we won't consider. That is called feature engineering process. Then we implement ANFIS model. Then from the ANFIS model, we will forecast what is the stock price will be in December month or in the 2026 January month, like that. Then the stock market, so there are some indicators. First thing is RSA. RSA means relative strength index. So relative strength index means it is from 0 to 100, how the price values are. Price values is going up or stock price values is coming down. So that is called relative strength. By analyzing the relative strength index, we can consider which the company share value is stable or company share the stock market value is going up or going down. So depends on if the lot of people purchase lot of shares, then what happens? The stock market will go up. Then if the people started to sell all the shares, then what happens? The stock market will really keep on coming down. Then we can also implement the moving average process, then exponential moving average process. Then the exponential moving average process, type of moving average, then we implement for the price, stock price, and also how the new information will provide better output. Then next thing is moving average convergence diversion. So it is a popular technical indicator used for stock price prediction for understanding the stock market trend, and also the we need to buy the shares or need to sell the shares, depends on this indicator. Then how we can implement fuzzy logic? So fuzzy logic we can implement for the numerical values. For example, if we take the stock market value is high or medium or low, depends upon the linguistic values, then we implement membership function. Then we can implement fuzzy rules. For example, the example rule is if stock market price is rising and the stock market volume is high, then the trend is bullish. So bullish means the stock market values are increasing. Then if if the stock market price is decreasing and the momentum is slow, then the stock market trend is bearish. So only there are two trend, bullish and bearish. Bullish means stock market is very good. Bearish means stock market values are getting weakened, getting coming down. Then using the neural network, the method gradient descent and also back propagation methods, so we can tune the parameters and also we can predict the correct stock market price. Then how we can train the ANFIS model? So we need to give the input of stock values. Then the errors are minimized. Then finally, we implement the overfitting process. Then based on the data validation, we get the output. Then what are the advantage over other methods? For example, if you implement the auto-regressive integrated moving average ARIMA model, then it cannot provide correct prediction of stock market because the correct stock market is volatile market. Then if you implement alone only the neural network, also it cannot provide better output. Then if you implement the statistical method like the regression models also cannot provide the correct prediction. So that is the reason we go for neuro-fuzzy model for the stock prediction. Then, for example, if we take the comparison of neuro-fuzzy method with other methods, then the neuro-fuzzy system achieved consistently higher forecasting. How we are telling means we implement some method like RMSE, root mean square error. So root mean square error means the prediction is providing less error or higher error. If higher error means we cannot implement that method. If less error means we can implement method. Second, we can with the second metric is MAE, mean absolute error. So mean absolute error also should be minimum. So third metric is MAPE, mean absolute percentage error. So if this kind of metric, the error ratio is low, then we can go for particular model. If the error ratio is high, then we can skip the model. We can go for some other better model. So for example, based on the some statistical data, so the graph is drawn. For example, if we implement ARIMA model, what is the root mean square error of 22.4? Then mean absolute error is 17.8. Then MAP mean absolute percentage error is 3.1. If we compare it the LSTM model, LSTM is the one of the deep learning model. Then ANFIS model, if we compare the three metrics error, then the ANFIS model, the error rate is low, 9.8, then 7.8, then 1.3. So that is the reason the adaptive neurofuzzy inference system, so it provides better prediction than other model like ARIMA and LSTM. Then if we compare neurofuzzy over other methods, for example, visual performance analysis, then how the data will predict, how the prediction will be done, how the predicted output will be better. Then we can also plot the graph. Then if we plot the graph, then the error variation, then comparing with the correct output and also the predicted output. So we have to minus the correct output minus predicted output, which output produces the error very less. Then if we compare the LSTM, ANFIS and ARIMA, only the neurofuzzy, it provide the only less error prediction in the data. The next thing is ANFIS residual analysis. The residual analysis is so we can compare. For example, if we predict 2026 January, how the Indian stock market, how the Mumbai stock market is, then what is the share value of Reliance or Bajaj Alliance or Tata company shares in 2026. Then now we can predict based on the historical data, based on the neuropathy model. Then 2026 we can get the correct output. Then from the correct output we can subtract our predicted output. That is called residual analysis. From the residual analysis, if we get the range of -20 to +20, that means prediction errors are moderate. So if we compare with other models, then the neuropathy model is providing only less error. Then from the histogram diagram also, it provides a better prediction. Then from the comparison of other methods, the interpretation of finding is the adaptive neuropathy inference system. It outperforms other models because it is a hybrid models. Then the practical implication also accuracy, then the interpretability and the less error ratio. Then the practically we can implement this model. Then when we take the rule interpretability, the knowledge extraction, if we implement neural network alone also, we cannot get the correct prediction. Since we go for hybrid model, it provides better output. Then what are the benefits is the hybrid model adapts well to the noisy and incomplete data. Noisy means even the stock market keeps go down, then keeps increase, keeps coming down, then the values keep on changing. Then it can be useful for neuropathy. We can be suitable for this one. Then incomplete data. Some values are missing also. Some values we cannot provide also. It automatically calculate the missing value, then provide the output. Then moreover, it captured non-linearity comparing with the classical models. The another thing is it neuropathy approach combine interpretability and also accuracy. So that is the reason neuropathy can be better than other models. So the conclusion is so neuropathy model is a robust, interpretable, and also adaptive approach. And also, since ANFIS model combines neural network and also fuzzy logic, it leads to high interpretability and then high data convergence. Then, moreover, uh, in case of handling uncertainty data and imprecise data and vague data, neuropathy model works better. Then, for example, future direction is so since if you want to implement for huge data set, then the neuropathy model cannot provide better output. So that is a limitation. Then, if you want to implement for large data set, then surely neuropathy model, the ANFIS model cannot provide better prediction. So need to go for hybrid with an ANFIS model with PSO, particle swarm optimization algorithm, or an neuropathy model with genetic algorithm, or neuropathy model with gray wolf optimizer algorithm. So like this type of algorithm will be hybrid. Then in case of large data set, it provide better output. Small data set neuropathy model will work. Then if you go for large data set and high complexity, large number of rules, then a neuropathy model cannot work. Then need to go for a better model like neuropathy model with PSO, particle swarm optimization, or genetic algorithm, or gray wolf optimizer, depends upon our situation. So another thing we can also integrate with the LSTM or GRU, Greater Recurrent Unit algorithm, to provide for enhancing better prediction performance. So these are the reference. So finally, I feel that so I give the overall idea of how what is neuropathy model, then how it can be implemented. I give you the case study for stock market. Then what are the benefits? Then what are the limitations of neuropathy model? Okay, so I feel I have enlightened the audience, enlightened the participant with some overview and also some basic knowledge, and also the working of the neural network and fuzzy logic, and the hybrid model of neural network and fuzzy logic neuropathy model. Okay. Any questions? So welcome. Organizers.
Excuse me, sir. Am I audible?
Yes, sir.
Okay. This any research work just extending this logic into multi-fuzzy logic? Is there any such
Pardon, sir?
sir? Is this research or this fuzzy logic?
Yes, sir.
Is it extended to multi-fuzzy or something like uh, extension of fuzzy sets?
Yes, sir. Sure, sir. We can implement. We can we can check the output. So once you just try with some pilot model, then small data set, then it provides a better output. Then surely we can develop some system or machine learning model.
Okay. Sir, you just mentioned about normalization. What's the theory of that normalization? How we do that one, the normalization? After falsification, that's data analysis and then normalization. How
Yes, sir.
we do
So
that one?
okay. So the normalization. So only the expert in the specific field. For example, if we implement neuroplasty in the brain MRI
Oh,
processing, then we need to get the output from. Then we need to get the expert advice from neurologist, then physiologist, then the scanning doctors. Then based on that one only, so we can first fix the rule. Then depends on the situation whether we are scanning the brain MRI or whether we are scanning the inner abdomen or kidney or any other organ. Then based on the specific human expert, then we can normalize the rule depends on the situation. So that is called normalization. We can frame the rules. Maybe rules the we can frame 1,000 number of rules. So out of 1,000 rules, so for in case of brain MRI scanning, of brain got various component like left lobe, right lobe, then hippocampus, so like that. Then as which area we implement, then those set of rules we choose, then remaining rule we skip. So that is called normalization. Normalization can be done only using one human expert in the specific field, sir.
okay, thank you, sir. Thank you, sir.
Okay, thank you, sir.
Evening, everyone. Is there any more queries? Am I audible?
Yes, ma'am.
Yes.
Okay, good evening, everyone. I am Shemima, Assistant Professor, Department of Computer Science, Majlis Arts and Science College. I will give a brief overview of neurofuzzy approaches for time series prediction and forecasting presented by Dr. E.J. Thompson Frederick, Professor, Department of Computer Technology, Karpagam Academy of Higher Education, Coimbatore. The session started with an introduction on time series forecasting, which aims to predict future values using past observations. The real world datasets, such as stock prices, weather, and demand, often contain trends, seasonality, noise, and sudden shifts. Traditional models like moving average, exponential smoothing, ARIMA, and seasonal ARIMA work well when data is linear and stationary, but they struggle when the pattern becomes complex or unpredictable. There comes the importance of neurophysiology, which combine the learning ability of neural network with the interpretability and uncertainty handling capability of fuzzy logic. This makes them ideal for real-world forecasting where data is noisy, non-linear, and imprecise. The ANFIS model, the Adaptive Neurofuzzy Inference System, it integrates the fuzzy system with neural network learning. It uses a 5-layer architecture that performs fuzzification, rule activation, normalization, and output computation. What makes ANFIS powerful is its hybrid learning algorithm. Least square estimation optimizes the output parameters, while gradient descent fine-tunes the membership functions. This results in fast convergence and high accuracy. To demonstrate its effectiveness, the model was applied to stock price forecasting, a domain known for volatility and nonlinear behavior. Inputs such as RSI, the relative strength index, MA, moving average, EMA, exponential moving average, MACD, moving average convergence divergence, were used to capture market trends. ANFIS was trained using historical price data and evaluated using standard metrics like RMSE, root mean square error, and MAPE, mean absolute percentage error. The performance of ANFIS model was compared with ARIMA and LSTM. ARIMA struggled with sharp market fluctuations. LSTM performed better, but ANFIS achieved the best overall accuracy. It produced the lowest RMSE, MAE, and MAPE values and tracked nonlinear fluctuations more effectively. The key strength of ANFIS were learn nonlinear relationship from data, handle uncertainty and noise, adapt to market regime shifts, produce interpretable if-then rules which are useful for decision support. It also works well even when the dataset is not very large, unlike deep learning models. The session directed the future works which may integrate ANFIS with optimization algorithms like PSO or genetic algorithms, or combine it with deep learning models such as LSTM or GRU. These are strong opportunities in renewable energy, IoT forecasting, and financial analytics. To conclude, in summary, neurofuzzy systems, especially ANFIS, provide a highly effective and interpretable approach to time series forecasting. They offer an excellent balance of accuracy, adaptability, and transparency, making them suitable for many real-world forecasting challenges. That's all. Thank you for listening.
Thank you, Shemima ma'am, and I would like to invite Miss Bigitra ma'am for the formal vote of thanks.
Is it audible?
Yes, ma'am, you are audible.
Hello? Okay,
Yes.
thank you.
Yes.
Respected dignitaries, esteemed resource person, and dear participants, a very good evening to all. It is my privilege and honor to propose the vote of thanks for this wonderful session. First and foremost, I extend our deepest gratitude to our esteemed resource person, Dr. E.J. Thompson Frederick, Professor, Department of Information Technology, Karpagam Academy of Higher Education, Coimbatore. Sir, your insightful session on neurofuzzy approaches for time series prediction and forecasting has enriched our knowledge and provided valuable perspectives that will surely benefit all participants. We are sincerely grateful for your time and expertise. Next, I express our heartfelt thanks to our respected principal and coordinator of this program, Dr. Mohammaduti sir, for the constant encouragement, guidance, and support that make program like this truly impactful. Our sincere appreciation goes to our program co-coordinator, Rafiq sir, whose meticulous planning and dedicated effort have ensured the smooth conduct of this FTP. We also extend our thanks to Professor P. Shantakumari ma'am, HOD Department of Chemistry, for the warm and gracious welcome address that set the right tone for today's session. A special mention to our rapporteur, Ms. Shemima Rahmat, Assistant Professor, Department of Computer Science, for effectively documenting and coordinating the session proceedings. We are equally thankful to Mr. Subhash sir for providing excellent technical support, ensuring that the online session ran seamlessly. Finally, a heartfelt thank you to all the participants for your active involvement and enthusiasm. Your presence and engagements are what make this program truly meaningful. Thank you all once again.